Hey guys, we're talking about Physics 101 today here at How Radiology Works. So specifically we're going to be talking about mechanical force, and make sure and stick around to the end so you know why we have a plague, just like right now we are in a pandemic, why we have a plague to thank for the discovery of force at the time. So again, mechanical force. So this is the basis for all of modern physics. This is what's called classical physics, and specifically 1686, and this is Sir Isaac Newton is really responsible for what we have in terms of the discovery of force at the time. There's always that story about the apple. I don't really believe that was a true story. It's an interesting story to talk about that the apple fell, he hit his head and realized there must be something that's causing that apple to fall and hit me. And he probably realized earlier than that he wasn't floating up in the air. But at any rate, what we're talking about when we talk about force is really, we're talking about if you have an object like this, if this object has a certain amount of mass, and then we want to push that object we're going to push against that object in a certain direction. What we call the force on that object is really just, if the object doesn't have anything pushing on it, it won't be moving at all. And what we talk about is really the force on that object is equal to the mass of that object multiplied by the acceleration. The acceleration is not the speed, but the change of speed. So if you start from zero and then you start accelerating or making the object move faster, that's what the acceleration is measuring here. So the units are really important whenever we talk about any physical quantity. So the unit of mass is basically how much matter is there, right? The standard unit for that is kilograms. And then the acceleration is, again, we're talking about how the change of speed. So we're talking about distance would be in units of meters. And then if we are talking about speed, we'd be talking about units of meters per second, so how fast something is moving. And then if we talk about the change of speed, we're talking about meters per second squared. So how fast we're changing in terms of that acceleration, that's equal to the force. And then we don't want to write this every time, so we give this its own unit. And like we talked about, this is responsible from Sir Isaac Newton, who actually discovered this physics, and in order to do so, he actually derived calculus himself, and he did so when he was held up in his room during the bubonic plague, or the Great Plague, in 1686. So, not as extreme in our current pandemic, but similarly where we're holed up in our houses more so. More people are learning how to bake sourdough bread, do things like that. I don't know if anyone has derived the next version of calculus as far as what the next great breakthrough is going to be, but that's really the tie-off that I wanted to talk about from the beginning. And in terms of this standard force, we now understand that as we push an object, as it gets accelerated faster, that is going to determine what the force is. The same thing if you think about, we have a great big Earth, right? And we have a great big Earth, and you are a little person not drawn to scale, you are a little person standing on that great big earth. So if we zoom in to our little person standing on that great big earth, we actually have what's called gravity, right, pulling down on us. And that gravity is going to be pulling down in this direction, and it has a constant pull. So the force down in this direction is just equal to the mass, and then this is times the acceleration, which is due to gravity. And that G is actually just 9.8 meters per second squared. Obviously, I'm rounding here. So that's the force pulling down on us. So when we talk about our weight, we're actually talking about something that's specific to being on the earth. We're saying on the earth, we weigh this much, or this much force is pushing down upon us. So we talked about newtons being units of force. On earth, pounds are also units of force. And 1 pound is equal to 4.5 newtons. So obviously that wouldn't hold if we're talking about being on the moon or something like that. But since I'm going to spend, I think, all of my waking hours on Earth, unless Elon calls me up and decides to send me up in a rocket. But until then, you know, I'll be spending all my time on Earth. So probably this is going to be, you know, good enough for our purposes. So you can calculate basically how much force is being exerted on an object, and all you need to do is know the mass and the acceleration. And then on Earth, we talk about having a constant acceleration pulling down. We call that G, and it just has one constant number here, which is around 9.8. So now you know about the very basics of force, very basics of classical mechanics.